Well, greetings, Mr. Colazar's class. We're going to continue in section 14.3. So this will be kind of like our 14.3 part 2. And I think it's number 23 in our notes. Somewhere about that area. But we're going to be looking at solubility graphs and solubility guidelines for soluble or insoluble products. So to start with our solubility graphs, remember this will be in our gold packet, or it'll be a reference page that you're going to be getting. And what it's going to look at is it shows the number of grams of solute, so what's being dissolved, that can be dissolved in 100 grams of water at different temperatures. So x-axis, our temperature. Water boils at 100, so that's where we'd stop there. So from 0 to 100 degrees, and then the solubility in grams of each one. So how many grams in 100 grams of water? So if we had 100 grams of water, 100 milliliters of water, how many grams of our solute can we dissolve in it? And each line on here represents the maximum amount of substance that can be dissolved at a given time. So like if we were to look at potassium nitrate, KNO3, as temperature goes up, the amount of solvent, or solute, that we can dissolve would also go up. So as temperature increases, generally the solubility, how much we can have put in, increases. There's a few, cesium sulfate, over here that actually decrease as we're going, and then we'll see other ones that don't follow the line, but generally you'll see the trend mostly goes in an upward direction as temperature increases. Now to look at these three types of solutions we can have. So type A, solution that contains a maximum amount of solute that can dissolve. So for A, we're right on the line. So identifying that you're right on the line for that first one. So as we're going right on the line, it contains the maximum amount of solute can dissolve. So right on the line. Whoops. Now adding more solute to it will not dissolve, and it'll settle on to the bottom because we've already dissolved the maximum that we can have. Our second type of solutions is an unsaturated solution. Unsaturated solution, if you fall anywhere below the line, means that we could actually add a little bit more to get to the line, so we could dissolve a little bit more into the solution. Now if we're below the line, that means we're unsaturated, meaning we could add more solute and the solute would dissolve. And our third one, supersaturated solutions. These are solutions that hold more than the maximum amount that remains that can be dissolved in there. Now the way we can do this is by adding slowly, created by slowly cooling to below the saturated solution. So if we have a certain amount dissolved here, and then we cool down, we should only be able to dissolve this much, and instead we have extra amount of solute that's actually been dissolved in. So by heating the solution up, we can dissolve more in, and slowly cooling it down, we can a lot of times keep more dissolved in than we should. So areas above the saturated line is how much we've dissolved. If we add more solute, the additional crystals, it'll actually crystallize out and form out. So we'll actually see supersaturated solutions. We'll be making those in lab to see what they actually look like. But we're holding more than we should be able to. So to identify some points, make sure your point A is right on the line. It might have gotten moved just over, so make sure it's right on the line. So point A, right on the line, is going to be saturated. That's the most that we can actually dissolve into the solution. Point B over here, what we're looking at is we've dissolved in more particles than we're allowed to have in there. So port B, supersaturated. To get B, or to get D, in this case, we would have had to have dissolved a certain amount, and then once we've dissolved that amount, what we would have had to do was cool it down. And as we cool it down, point B and point D or to go to B, as it's cooled down, we have way more particles dissolved in than we can actually have. C, underneath the line, we could still dissolve in more, so it's unsaturated. And finally, we'd already seen D earlier, not quite as supersaturated, but D, still more particles than we should be able to have in there. So what would have had to happen is we got to point A and then cooled it back down to get to either B or D. The other part of solubility we're going to look at, little charts. We showed a few extra on this one, the gold packet. NH3, a gas, as we heat up, actually decreasing the amount, cesium sulfate decreasing, but generally moving on up. Percent by mass from earlier, the amount of solute that we can actually dissolve. So just seeing that equation again. Solubility tables. So our solubility tables found in your gold packet, we might have moved them slightly from page 3, but our solubility tables are going to be useful when we're predicting whether or not a precipitate, the insoluble, will form when two ionic solutions are mixed. So precipitate is the insoluble. So an example here, our chart shows soluble compounds. So if you're soluble, that means you're going to dissolve. All of these are soluble. So if you contain any of that, you're automatically soluble. The exceptions to this are if you have a halide example, if it's combined with one of these three elements, or if you have sulfates and it's combined with one of these 5 elements. On the opposite chart, insoluble, meaning that they don't dissolve. All of these are insoluble except if we have one of these elements along with them. So either the group 1 or NH4, and then down at the bottom calcium, bromine, strontium, mean that those would be soluble. So let's try this out. Silver nitrate and sodium chromate solutions are mixed together. Will a precipitate form? And if so, what is the name of the precipitate? So first off, we have a double placement reaction. So silver plus nitrate is going to produce sodium and chromate, or sodium chromate. So when this reaction happens, the positive goes with the negative of one and the positive of the other goes with the negative to produce silver and chromate are going to combine and sodium and nitrate are going to combine. So the question is, which of these two is soluble and which one will form the precipitate? So silver chromate and sodium nitrate. So looking on that chart, let's see, all group 1 ions, so sodium, would automatically be soluble. And the other one we're looking for all of our chromates are insoluble except when they're mixed with group 1. So if they're not with group 1, all chromates are insoluble, all these are soluble. So in the end, our insoluble product is the silver chromate solution, or excuse me, silver chromate would be the precipitate. And our last one, sodium hydroxide and copper 2 sulfate solutions are mixed. What will a precipitate form, and if so, what is the name of it? So sodium hydroxide and copper sulfate are going to combine to form copper hydroxide and sodium sulfate. So the question is, which of these two are soluble? So looking back, all of our sulfates, where did the sulfates go? All the sulfates are soluble except when they're combined with these elements. And then our other one, all of our hydroxides are insoluble except when they're combined with these elements. So to look, hydroxide mixed with copper, all of our group 1 elements are automatically soluble. So in the end, copper hydroxide is our insoluble one. We'll continue looking at soluble versus insoluble in our solubility graphs as we're going forward.